Welcome to the last lecture in mechanics of materials. In this lecture, we will solve two boundary value problems, find the stresses in the body and utilize the failure theory that we have learned to ensure that the applied load is less than a particular value, so that the body does not fail. Okay. First problem that we are going to look at is a thin wall pressure vessel pressurized from inside and subjected to an external pressure P e, which is alpha times the internal pressure P I. This pressure vessel has a diameter of 2 times r m, or r m is the radius of this vessel and T is the thickness of the vessel. Okay. Now, we want to find what is the maximum pressure, internal pressure that can be applied P I, such that this body does not fail by yielding. Okay. So, we assume that the material obeys Tresca failure criteria and has a uniaxial yield stress value of sigma y u e. Okay. So, now we want to find out what will be the pressure, internal pressure that can be applied as a function of alpha, so that this body does not fail. Okay. Since we know from by Tresca failure criteria, what we mean is the maximum of the absolute value of the principal stresses sigma 1 minus sigma 2, sigma 2 minus sigma 3, sigma 3 minus sigma 1, 1 half of this, that is the tau max, the maximum shear stress in the body should be less than or equal to kappa. Okay. And we know that for uniaxial state of stress, sigma uniaxial is given by, can be written in this form 0 0 0 0 0 0 0 0. Now, tau max or the maximum shear stress in this, for this state of stress, uniaxial state of stress is 1 half maximum of absolute value of sigma 0 absolute value of sigma, which will be sigma by 2. Okay. And you know that the maximum stress that it can take in uniaxial is given by sigma y by sigma y u e, and hence kappa has to be sigma y u e by 2. Okay, because that is a stress at which the uniaxial state of stress begins to yield. Okay. So, kappa has to be this. So, now putting all this together, we know that we have found the kappa, the metal parameter in the failure theory, Tresca failure criteria. So, you have now you have to limit maximum of sigma 1 minus sigma 2, absolute value of that sigma 2 minus sigma 3, absolute value of sigma 3 minus sigma 1 should be lesser than or equal to sigma y u e, substituting for kappa here as sigma y u e by 2. Okay. Now, let us go over to the boundary problem that we are interested in. In a thin walled pressure vessel, you know that the state of stress can be written as, you assume there is no radial stress and there is only OOP and axial stresses 0 0 0 sigma axial. Okay. Now, what I have done is I have assumed r m by T is greater than 10. Okay. So, I can assume the pressure vessel to be a thin walled vessel, so that the OOP stress, as we saw in the previous lectures, is given by P I minus P E into r m by T, which in our case will be P I into 1 minus alpha r m by T. Okay. Similarly, the axial stress is given by P I r m by 2 T. I am assuming the external pressure is not contributing to the axial stress. Okay. We gave an argument why it will won't when we saw thin wall pressure vessels. Okay. So, this is given by P I r m by 2 T. Okay. So, now for this sigma 1 would be 0, sigma 2 would be P I r m by T into 1 minus alpha, and sigma 3, the third principal stress would be P I r m by 2 T. substituting these values into the star equation, what we get is, we get maximum of pi Rm by T, absolute value of 1 minus alpha comma pi Rm by T, absolute value of 1 minus alpha minus 1 by 2 comma pi Rm by 2 T must be lesser than or equal to sigma y u e. What this tells us is, this tells us that pi into maximum value of absolute value of 1 minus alpha 1 minus 2 alpha by 2 comma 1 by 2 must be less than or equal to sigma y u e T by Rm. Okay. Now, your task is to find out what is this maximum value of this thing as a function of alpha. You know that it is given that alpha is greater than 0 because I am fixing up the direction of the external pressure as acting radially inward. Okay. So, the alpha is greater than 0, that information is known to us. Now, we have to find the maximum value of this subject to the constraint that alpha is greater than 0, which is given to us because we have fixed the direction of the externally acting pressure as being radially inward, and hence this alpha has to be greater than 0. Okay. So, basically now what we are interested is, we are interested in finding the maximum value of this subjected to the constraint that alpha is greater than 0. Okay. So, there will be 3 cases that we have to consider. Let us do it case by case. Case 1, we want 1 minus absolute value of 1 minus alpha to be lesser than or equal to half, and absolute value of 1 minus 2 alpha by 2 also must be lesser than half, in which case the maximum value would be, half, and hence pi must be lesser than or equal to 2 times sigma y u e T by Rm. This implies if these two holds, you know that this one is lesser than half, this quantity is lesser than half, this quantity is lesser than half. So, the maximum value of these 3 quantities will be half. Okay. So, if the maximum of these 3 quantities is half, it is pi by 2 must be lesser than or equal to this quantity, which means pi must be lesser than this quantity. Now, we have to find out what restriction this places on, this condition and condition places on alpha. Okay. So, to do that, what we will do is, first we will consider this term. What I want is, I want 1 minus alpha should be greater than 0. If 1 minus alpha is greater than 0, then 1 minus alpha has to be, and 1 minus alpha must be lesser than half. Okay. If 1 minus alpha were to be lesser than 0, then the absolute value of that would be alpha minus 1. Okay. The next condition is or 1 minus alpha can be lesser than 0, in which case the absolute value of that would be alpha minus 1, which must be lesser than half. Okay. Now, what does this condition tell me? This condition tells me that alpha must be lesser than or equal to 1 and alpha must be greater than or equal to half, right. Okay. So, combining these two conditions, alpha must be lesser than 1 and alpha must be greater than half, means alpha must lie between half and 1. That is what this tells us. Okay. Let us look at what the second condition tells us. The second condition tells us that alpha must be greater than or equal to 1 and alpha must be lesser than or equal to 3 by 2. Okay. This tells us that alpha must vary between 1 less than alpha less than 3 by 2. Okay. So, to satisfy this condition alpha must lie either between half and 1 or 1 and 3 by 2. Okay. Now, let us explore what happens to this second condition. The second condition will tell us that again there will be two cases. One is 1 minus 2 alpha is greater than or equal to 0, okay, and in which case 1 minus 2 alpha is positive. So, absolute value of that will be 1 minus 2 alpha. This should be lesser than or equal to 1, the 2 gets cancelled. Okay. Now, what will this tell us? This tell us that alpha must be greater than or equal to, no, alpha must be lesser than or equal to half, and it tells us that alpha must be greater than or equal to 0, right. Okay. So, combining these two you get the requirement that this should lie between alpha 0 and half. Okay. Now, the second requirement here is 1 minus 2 alpha is less than or equal to 0, and in which case absolute value of that will be 2 alpha minus 1, and this should be lesser than or equal to 1. Same argument, 2 gets cancelled here. So, I have this inequality in here, okay, in which case alpha must be greater than or equal to half and alpha must be less than or equal to 1, which will tell me that alpha must lie in the range 1 half less than or equal to alpha less than or equal to 1. Okay. Now, combining these all these two inequalities, it is a AND condition there, alpha must lie between half and 1 or 1 and 3 by 2. In this case it should lie between 0 and half or half and 1. Okay. The common overlapping domain between these two cases is half and 1. Okay. So, you get the condition that this condition holds when alpha lies between half and 1. Okay. So, you got that this condition is between alpha lying between half and 1. Okay. Now, let us move further. You have to consider next case. Case 2 would be when I want, now I have ensured that half is now the greatest of the quantities that I have looked at. Next I will ensure that 1 minus 2 alpha by 2 is greater than any of the other 2. Okay. So, in which case what will be the condition would be absolute value of 1 minus alpha must be lesser than or equal to absolute value of 1 minus 2 alpha by 2 and 1 half must be less than or equal to absolute value of 1 minus 2 alpha by 2, right. Okay. So, reverse of that condition. So, again if this were to be true then Pi must be, this were to be true then Pi should be lesser than or equal to 2 times sigma y u e t divided by r m into absolute value of 1 minus 2 alpha. Okay. Let us resolve what that absolute value is when we give the restriction on alpha. Okay. Like before we have to look at different cases, but now there will be 4 cases for this inequality, there will be 4 cases for this inequality and 2 cases for this inequality, because there is absolute sign on either side of the inequality. Okay. So, first we will look at the second one. Looking at the second one, I want 1 minus 2 alpha to be greater than or equal to 0, okay, and in which case I want 1 to be less than or equal to 1 minus 2 alpha. Okay. What does this tell us? This tells us that alpha must be less than or equal to 1 half and I have alpha must be less than or equal to 0. This is not possible. So, this is a not possible case, this is not possible. Okay. Now, let us look at the second case. Second case would be 1 minus 2 alpha is less than or equal to 0 and 1 should be lesser than 2 alpha minus 1. Okay. Since this is less than 0, the absolute value of that will be positive when it is 2 alpha minus 1. Okay, that is what I have used. This will tell us that alpha must be greater than or equal to half and alpha must be greater than or equal to 1. Okay. So, combining these two, I get the condition that alpha must be greater than or equal to 1. Okay. Now, let us go back and look at what this restriction tells us. Okay. First case is 1 minus alpha is greater than or equal to 0 and 1 minus 2 alpha is greater than or equal to 0, in which case I will have 1 minus alpha must be lesser than or equal to 1 minus 2 alpha by 2. Okay, both are positive. So, I have indicated their positive values here and remove the absolute sign. Now, what will this tell us? This tells us that alpha must be less than or equal to 1 and alpha must be less than or equal to half and 2 is less than or equal to 1 is what condition will get, which is not true. Hence, this is a not possible scenario. This is not feasible scenario. Okay. Next, let us look at the next condition where 1 minus alpha is less than or equal to 0 and 1 minus 2 alpha is greater than or equal to 0, in which case absolute value of 1 minus alpha would be positive for alpha minus 1. Okay. And this should be lesser than or equal to 1 minus 2 alpha. This is again positive because 1 minus 2 alpha is positive divided by 2. Okay. Now, what is the condition you get? You get alpha must be greater than or equal to 1, okay, and alpha must be less than or equal to half and alpha must be less than or equal to 3 by 4. Okay. Now, combining all this, what you will get is, you will get it as alpha must be greater than 1 and less than 3 by 4, okay, which is not possible. Okay. So, there is no it is not possible that alpha can be greater than 1 as well as less than 3 by 4. So, this is a not possible solution, possible to find such an alpha. Okay. Next, let us consider the next case, which will be 1 minus alpha is less than 0 and 1 minus 2 alpha is less than 0, and since 1 minus alpha is less than 0, the positive value will be alpha minus 1. This should be lesser than 1 minus 2 alpha is less than 0. So, positive value will be 2 alpha minus 1 by 2. Okay. So, what will this tell us? This tells us that alpha must be greater than or equal to 1 and alpha must be greater than or equal to half and minus 2 is less than or equal to minus 1, which is true. Okay. Always this implies that alpha must be greater than or equal to 1. Okay. The final case that we have to consider is 1 minus alpha is greater than or equal to 0 and 1 minus 2 alpha is less than or equal to 0, and since 1 minus alpha is greater than 0, it will be 1 minus alpha should be lesser than 1 minus 2 alpha is less than 0, the positive value will be 2 alpha minus 1 by 2. Okay. Now, for this case you will find that alpha must be less than or equal to 1 and alpha must be greater than or equal to half, and here and alpha must be greater than or equal to 3 by 4. Okay. So, here alpha must be lesser than half, lesser than 1 and greater than 3 by 4, which means alpha can lie between 3 by 4 less than or equal to alpha less than or equal to 1. Okay. Now, the common domain, you have to satisfy these two restrictions along with this restriction on, you have to satisfy these two restrictions along with the restrictions on this side. So, the common domain here is alpha greater than 1. Okay. So, this will become possible if alpha is, this is if alpha is greater than or equal to 1. Okay. If alpha is greater than or equal to 1, what happens? 1 minus 2 alpha will be lesser than 1. So, the correct way to write this condition would be Pi must be lesser than or equal to 2 sigma y u e t divided by r m to 2 alpha minus 1. I remove the absolute sign now, okay, because I know that when alpha is greater than 1, this will be negative, and hence absolute value will be this for alpha greater than or equal to 1. Okay. Now, the next case that we have to consider is the following. Now, we have assumed that this is greater than in one case and this is greater in the other case. I have to assume that this is greater in the third case. Okay. So, if I assume that that is greater in the third case, what I will get is the case 3 which will be similar to case 2, except that 1 minus 2 alpha by 2 must be lesser than or equal to absolute value of 1 minus alpha, and I will have 1 half should be lesser than or equal to absolute value of 1 minus alpha. Okay. In which case this will imply that the maximum value is 1 minus alpha. So, should be lesser than or equal to sigma y u e t by r m into absolute value of 1 minus alpha. Okay. Now, I have to go through the same procedure again what I did for case 2 to show that this will hold when alpha is less than half, to show that this will hold for alpha less than or equal to half, between 0 and half. Okay. Let me do that. So, first let us look at this inequality. So, now what I will have, I should have 1 minus alpha is greater than 0 and 1 half should be lesser than or equal to 1 minus alpha, which will tell me that alpha must be less than 1 and alpha must be lesser than or equal to half. Okay. This implies that alpha must lie between 0 and half, 0 because alpha is bounded to be greater than 0, okay, from our general restriction. The second restriction here is if 1 minus alpha is less than 0, less than or equal to 0, and if this is less than 0, I should have 1 half must be less than or equal to alpha minus 1, okay, in which case what I will get is I will get alpha to be greater than or equal to 1 and alpha must be greater than or equal to 3 by 2. Okay. This will imply that alpha must be greater than or equal to 3 by 2. Okay. These are two possible solutions here. Now, coming on to the other side, just like before, I will have, let me assume 1 minus 2 alpha is greater than or equal to 0 and 1 minus alpha is greater than or equal to 0 and 1 minus 2 alpha is positive, should be lesser than 2 times 1 minus alpha, which is also positive. Okay. Now, what we will get is we will get that alpha must be less than or equal to half and alpha must be less than or equal to 1 and 1 is less than or equal to 2, which is always true. Okay. So, the general condition here is alpha, this implies alpha must be less than or equal to half. Okay. Now, the second condition is and I have alpha greater than 0, which is implied here. Okay. So, the second condition would be 1 minus 2 alpha is less than or equal to 0 and 1 minus alpha is greater than or equal to 0 and since 1 minus 2 alpha is less than 0, I will have 2 alpha minus 1 must be less than or equal to 2 times 1 minus alpha. Okay. What this will tell us is, it will tell us alpha must be greater than or equal to half and alpha must be less than or equal to 1 and alpha must be less than or equal to 3 by 4. Okay. So, here the common ground is, this will imply that alpha must be between 1 and 3 by 4, 3 by 4 less than or equal to alpha less than or equal to 1. Okay. The next condition is 1 minus 2 alpha less than or equal to 0 and 1 minus alpha is less than or equal to 0 and 2 alpha minus 1, because 1 minus 2 alpha is less than 0 must be less than or equal to 2 times alpha minus 1, again because 1 minus alpha is less than 0. Okay. Now, what will this tell us? It will tell us alpha must be greater than or equal to half and alpha must be greater than or equal to 1 and minus 1 is less than minus 2, which is not true. Okay. So, this is not feasible, this is not feasible option. Okay. And now the final condition is, 1 minus 2 alpha must be greater than or equal to 0. I did 2 less than zeros and 1 greater than 0. Here I have 2 greater than zeros and 1 less than 0 for 1 minus alpha. So, it will be 1 minus alpha must be less than or equal to 0 and 1 minus 2 alpha is greater than 0. So, 1 minus 2 alpha must be less than or equal to 2 times 1 minus alpha is less than 0. So, I will have it as alpha minus 1, the absolute value to be positive. Okay. What will this tell us? This tells us that alpha must be less than or equal to half and alpha must be greater than or equal to 1 and alpha must be greater than or equal to 3 by 4. Okay. Now, this is again not possible because alpha can't be greater than 1 and less than half at the same time. So, this is a not possible solution. Okay. So, again combining these domains, in this domain you need alpha to be less than half and alpha must be less than half even here. Alpha must be greater than 3 by 2, which is not possible in this domain. So, the common domain is alpha must be less than half. Okay. So, this will be the domain for this 0 less than alpha less than half will be the domain for this thing, in which case 1 minus alpha is positive and hence the right way to write this inequality is Pi must be less than or equal to one minus alpha, removing the absolute value when 0 less than alpha less than or equal to half. Okay. So, this is for 0 to half, you have that this is the inequality 0 to half, you have this restricting the value of Pi. If the value is greater than 1, you have this inequality restricting the value of Pi, and if alpha lies between 0 and 1, you have this inequality restricting the value of Pi. Okay. So, now all the domains 0 to infinity you have some restriction on Pi. Okay. So, that completes this problem. So, you find a Pi corresponding to what value of alpha you have.
Okay.